try to find in your notes the 4 things that we talked about on Tuesday that you need to have on graphs of general rational functions. You're going to want those notes out for the rest of today so that you can refer back how to find these 4 things. On the graphs of general rational functions, you need horizontal asymptote, vertical asymptote, x-intercept, and y-intercept. So you're going to be taking notes over chapter 8.3, graphing general rational functions. We're going to keep doing graphs of general rational functions that Monday and Tuesday when we get back from spring break, and you will have a quiz on Tuesday over 8.1 to 8.3. This is in general what the graph of a rational function looks like. You have in your notes f of x equals p of x over q of x. All we're saying is that it's a function divided by another function. The part at the end is showing you that it's a higher degree polynomial. You've seen this definition of a higher degree polynomial last semester when I introduced polynomials to you. So all of the a sub m's in the numerator, those are just coefficients. X to the m, that's your highest power. Next to that, you'll see x to the m minus 1. All that's saying is that the power is decreasing by 1 in each term. You have an ellipse because you can have as many terms in there as you want. And then at the end, x to the first power, and then your last a sub 0 is just a constant. The same thing is happening in the bottom. That's just saying we have a higher degree polynomial over a higher degree polynomial. So for example, it might look like 4x cubed minus 2x squared plus 3 over x squared minus 5. Those are the types of graphs we're going to be looking at. So general rational function graphs must have a vertical asymptote. And you should have in your notes from Tuesday how we find that. They must have a horizontal asymptote. We have kind of 3 criteria that we look at to be able to tell what horizontal asymptote you're going to have. Notice we have m and n here. M is the degree of the numerator. Look at that definition up top. You'll see m is the degree. So m is the degree of the numerator. And n is the degree of the denominator. So this first one says, if m is less than n, if the degree in the numerator is less than the degree in the denominator, your horizontal asymptote is y equals 0. If they're the same, this is what we learned on Tuesday, then it's the ratio of the leading coefficients. If the degree in the numerator is greater than the degree in the denominator, you do not have a horizontal asymptote. So you'll just say none. Now, if you don't have a horizontal asymptote, you have something else called a slant asymptote. We don't actually find the equation of these things, but we are going to talk a little bit about them when we get back from spring break. Let me draw you a picture of what a slant asymptote would look like. You would still have a vertical asymptote, but a slant asymptote would be something like this. It might look like a linear equation with a positive or a negative slope. And then your branches would be somewhere in here. So you get these kind of strange looking graphs. Asymptotes tell us the end behavior of a graph. So even though we won't find the exact equation of that slant asymptote, I need to know if it would have a positive or a negative slope so I know what the end behavior of my branches are. So when we get back from spring break, we'll be finding the end behavior of our branches. And the way we do that is it's y equals the ratio of the leading coefficient that's the coefficient in front of x, and then x is to the m minus n power. So what usually happens is you'll have something like y equals 2x. That tells you it has a positive slope. So that'll tell me what n behavior my branches should have. So we will talk more about that after spring break. You won't actually do any examples of that today. The last two things, well, three things, you need to have the x-intercept, which you should have in your notes from Tuesday, the y-intercept. The last thing is new. It's called a hole. You might have hole, or you could have more than one, in your graph. Holes occur when you have a factor in the numerator that's the same in the denominator. So for example, if I gave you a rational function and it was y equals x minus 4 over x minus 4 times x plus 2, and I told you to graph it. Notice how there's an x minus 4 in the numerator and in the denominator. If I was simplifying these, I would say that those cancel out because it's just 1. So I have a point of discontinuity where that factor is. So I'm going to take that factor and set it equal to 0, solve for x. That means there is a hole on my graph at x equals 4. I do not exist at that point. So we will literally draw an open circle at x equals 4 on any graph that has a hole because it doesn't exist at that point. And we'll do one example of that today. All right, at any point in the video, if I'm going too fast, just pause it, get written down what you need, and then keep going. So in these three examples, we aren't going to actually graph them. We're just going to find the 5 key characteristics, and then you are going to graph it in your graphing calculator to get an idea of what it would look like. When you get these general rational functions, you need to always factor them first. So if you notice something in the numerator or in the denominator that can be factored, do that. So I've got negative 10. I have x squared minus 9 in the denominator. That's a difference of 2 squares. So that can get factored into x plus 3, x minus 3. Once you get it factored, then move on to find the characteristics. To find the vertical asymptote, I take the denominator and I set it equal to 0. So I've got x plus 3 equals 0, x minus 3 equals 0. So I'm actually going to have 2 vertical asymptotes at x equals 3 and negative 3. I don't have any holes because there's nothing in the numerator that's the same in the denominator, so I'm just going to say none. For the horizontal asymptote, I look at the degree. The degree in the numerator is 0, and the degree in the denominator is 2. So m is less than n. If you look back at your notes from the last slide, that tells you you have a horizontal asymptote at y equals 0. To find the x-intercept, I take the numerator and I set it equal to 0. Again, you have that in your notes from Tuesday. So 0 equals negative 10. That's not a true statement. Therefore, I have no x-intercept. For the y-intercept, I substitute 0 for x. So y equals negative 10 over 0 squared minus 9. So y equals negative 10 over negative 9. So the y-intercept is 0, 10, 9. So about 1.11 repeating. So what I'd like you to do now is pause the video and put this in a graphing calculator. You have to be careful when you put it in y equals. You need to put negative 10 in parentheses and divide by x squared minus 9 in parentheses. Make sure you have a standard window on your screen. Once you graphed it and notice the vertical asymptotes, the horizontal asymptotes, and the y-intercept, let's try this next one. X minus 5 over x squared minus 7x plus 10. Again, the first thing you need to do is factor it. So I'm going to factor the denominator into x minus 5, x minus 2. You should notice that there's an x minus 5 in the numerator and in the denominator. That should tell you that you're going to have a whole. I'm going to cross it off just so that you remember that we don't exist at that point. So I'm going to do the whole first. X minus 5 equals 0. So there's a whole at x equals 5. You do not exist at that point. If it's a whole, it can't be a vertical asymptote, it can't be a horizontal asymptote, or an x-intercept, or a y-intercept. So when I find the vertical asymptote, I'm going to take the denominator and set it equal to 0, but I'm going to ignore x minus 5 because I don't exist there. So my only vertical asymptote is at x equals 2. For the horizontal asymptote, I look at the degrees. The degree in the numerator is 1. The degree in the denominator is 2, so m is less than n. That tells me I have a horizontal asymptote at y equals 0. X-intercept, I take the numerator and set it equal to 0. That would give me x equals 5, and I don't exist at x equals 5, so I don't have an x-intercept. The y-intercept, I plug in 0 for x, so y equals 0 minus 5 over 0 squared minus 7 times 0 plus 10. That's negative 5 over 10, which is negative 1/2. That's the point 0, negative 1/2. So again, I want you to pause the video and I want you to graph this. Put the whole numerator in parentheses, the whole denominator in parentheses. If you have a TI-84 color, look really closely at x equals 5 and your calculator will actually skip over that point and show you where the hole is. The TI-83s and the regular TI-84s do not do this. If you have a color one, you should be able to see that. All right, once you've graphed it, let's do the last one. We have to start by factoring. You should recognize that in the numerator, I have a coefficient in front of x squared, which means I need to do a C method. So I'm going to do my work off to the side real quick. I need factors of negative 40, because that's a times c, that add to negative 3. And then I'll split up the middle term using those two numbers. So factors of negative 40 that add to negative 3 are negative 8 and 5. So I've got 2x squared minus 8x plus 5x minus 20 factor by grouping. So pull out 2x, then you're left with x minus 4. Pull out 5, you're left with x minus 4. So your factors are 2x plus 5 and x minus 4. So this factors into 2x plus 5 times x minus 4 over x squared plus 1. You cannot factor x squared plus 1. It would be a difference of squares if it was minus 1, but since it's plus 1, you can't do anything with it. So I'm going to find the 5 characteristics. Vertical asymptote, set the denominator equal to 0. So we've got x squared equals negative 1. Then I get x equals the square root of negative 1. That's imaginary. So I don't have a vertical asymptote. I also don't have any holes because there's nothing in the numerator that's the same in the denominator. The horizontal asymptote, you're going to take the numerator and set it equal to 0. So you're actually going to have 2 of them. So you're going to have a horizontal asymptote at negative 5/2 and x equals 4. When you graph this thing in your graphing calculator, it's going to look like you only have the one at x equals 4. You can actually cross the horizontal asymptote, and we'll get more into that after spring break, but that's why it doesn't look like you have two horizontal asymptotes on your graphing calculator. Alright, I'm sorry, those two should be for x-intercepts. So your x-intercepts were what I just had written down, x equals 5/2 and x equals 4. Your horizontal asymptote, we look at the degrees. So since the degrees are the same, m equals n, you're going to have y equals 2/1. That's the ratio of the leading coefficients. So it's just y equals 2. And then your y-intercept, you'll plug in 0 for x. So you end up getting y equals negative 20/1. So your y-intercept's way down at negative 20. So I'll write that as an ordered pair. It would be 0, negative 20. So again, take a second and graph that. Put the whole numerator in parentheses, the whole denominator in parentheses, and see what it looks like. This one looks a little bit different than the other two since it doesn't have a vertical asymptote. Alright, so now we're actually going to graph 3 of these. They're all going to be examples of the degree in the numerator being less than the degree in the denominator. So the first thing you should do is factor. So I'm going to rewrite this as negative 3 over x plus 2x minus 2 because it's a difference of squares. And then I'm going to list all of my key characteristics. We're going to have two vertical asymptotes at negative 2 and 2 because that's what I get if I set the denominator equal to 0. M is less than n, so my horizontal asymptote is y equals 0. I don't have any holes because there's no factors in the numerator that are the same in the denominator. My x-intercept, take the numerator, set it equal to 0. 0 does not equal 3, so I don't have an x-intercept. Y-intercept, plug in 0 for x, so negative 3 over negative 4. So that's the 0.034. Again, if I'm going too fast, just pause the video, write down what you need, and then keep going. So let's draw what we have. I've got two vertical asymptotes. And a horizontal asymptote. I also have a y-intercept at 0, 3/4. So right about there. So that doesn't really tell you what the graph looks like. So you need to go back and make a t-chart and pick x values to plug in. So my hint to you is to pick x values to the left of the vertical asymptote, in the middle, and to the right, because you know you're going to have a branch in all of those spaces as you saw in your graphing calculator. So I'm going to make a t-chart, and I'm going to use the numbers negative 4, negative 3, negative 1, 1, 3, and 4. You can pick whatever you want. I just picked those because they're to the left of the asymptote, in the middle, and then to the right. So pause the video and find those outputs. Take the x values, plug them into the beginning, and find the outputs. So you should get negative 0.25, negative 0.6, 1, 1, negative 0.6, and negative 2.5. Make sure those are the ones you're getting. I want you to make sure you know how to plug them in and simplify to get the outputs. So I'm going to plot these real quick. and connect them to make your picture. All right. Let's try another one. X plus 4 over x squared minus 16. Again, we're going to factor. So that factors into x plus 4 over x plus 4 times x minus 4. List your 5 characteristics. Alright, so you should notice that you have a factor in common. You have an x plus 4 in the numerator and the denominator. That tells you that you have a whole at x equals negative 4. Because if you take that factor and you set it equal to 0, you'll get x equals negative 4. So from a vertical asymptote, you're going to take the denominator and set it equal to 0. You're only going to set x minus 4 equal to 0 because the other one is a point of discontinuity. So it cannot be a vertical asymptote if it's already a whole. Horizontal asymptote, the degree in the numerator is less than the degree in the denominator, so it's y equals 0. Your x-intercept, you would take the numerator and set it equal to 0, but then you get negative 4, and that's a whole. So you don't have an x-intercept. Your y-intercept, plug 0 in for x, so you get 4 over negative 16, which reduces to negative 1/4. So I'm going to plot the vertical asymptote, the horizontal asymptote, and the y-intercept. That's all you have. So again, not a good picture. So you need to make a t-chart and plug in x values. I'm going to pick one more point to the left of the vertical asymptote and 2 to the right. You can plot as many points as you want until you have a picture of what it looks like. So to get a better idea, I think I'll do 2 and 3. Those are to the left of the vertical asymptote, and then 5 and 6. So pause the video, plug those in, and get your outputs. So you should have gotten negative 0.5, negative 1, 1, and 0.5. So 2 down a half, 3 down 1, 5 up 1, 6 up a half. So I'm going to do the bottom branch first. Go through your 2 points. Stop when you get to x equals negative 4. We don't exist there. So you're literally going to draw a hole in and then have your graph keep going. And then you'll have a branch at the top right too. Okay, so that's what a hole looks like on the graph. It's just an open circle. We're saying we don't exist at that point. Alright, this is your last one. It's a U-track. So I want you to pause the video and try this one on your own. And then when you think you've gotten it, check your answer. So what you're going to do first is factor. So 2x over x plus 1, x minus 1. List your characteristics. You're going to have a vertical asymptote at 1 and negative 1. Horizontal asymptote at y equals 0 because the degree in the numerator is less than the degree in the denominator. You're going to have no holes because there are no factors that are the same. You're going to have an x-intercept at 0 because if you set the numerator equal to 0 and solve for x, you get 0. For the will get 0 over 0 minus 1, which is just 0. So draw in the asymptotes at 1, at -1, and at 0. And then we have a point at the origin. Notice it's on your horizontal asymptote. As I was saying earlier, you are allowed to cross horizontal asymptotes. You are never allowed to cross vertical asymptotes. So this will be the first case that you guys see where you do actually cross the horizontal asymptote. So you should know that there's going to be a branch to the left of the vertical asymptote, in the middle of them, and then to the right. So you're going to pick points in all of those places. So I'm going to do -3, -2, -0.5, 0.5, 2, and 3. So you should have gotten out -0.75, -1.33, 1.33, -1.33, 1.33, and 0.75. If you have those as fractions, that's great. So now that you have those points, go ahead and plot them, and you'll get a picture. So there's your branch in the bottom left. In the middle, you actually have something that kind of looks like a cubic function from last semester. And then you've got a branch in the top right. So there's a case where you can actually cross the horizontal asymptote.